I'm Carly Miller from the University of Illinois, and today we're going to be discussing the specifics of the class Mammalia. So we're in the phylum Chordata, the subphylum Vertebrata, and the class Mammalia. In addition to behavioral and soft parts that are specific to the class Mammalia, there are also a number of key skeletal features that we want to examine today. So we'll be very specific about what those are and what comprises the class Mammalia. So the first key feature that humans make great use of is the enlarged brain case of mammals. So what we're talking about here, when we're talking about enlarged, we're referring to the ratio of the brain case size to the overall skull size. So this is the skull of a cat, for example. And so the brain case is the area of bone that surrounds the brain. Makes sense here. And if I could just compare the cat's brain case size to, for example, this little reptile. And so the brain case on the cat, you could actually point to it. You could identify it fairly easily. But the brain case in this reptile is right in the center here. I would estimate about the size of a peanut, for example. And so if you look at the size of the brain case, again, in comparison to the overall skull size, that is actually greatly enlarged in the class Mammalia. So this is the first key character of the class Mammalia. So if we go back to to considering our cat skull here, our mammal, one of the functions or the outcomes of having an enlarged brain case, again, we're talking about the ratio of the size of the brain case to the overall skull. An outcome is that mammals have an increased degree of muscle coordination, they're generally more intelligent, and their memories are a little bit more developed. The second key feature is that there's a single external nares. So that is basically the fossa, or the hole that goes through the front of the skull. So we're looking at the nose region here, and there's just a single opening there in the class Mammalia. And you might think of, if you can think of a human skeleton, you might notice that there's actually a septum there, but it's partially composed of cartilage, and so that opening is still considered one opening. So that's a single external nares. So if we can compare that to the external nares of a reptile, for example, so outside the class Mammalia, we'll notice that there are more than one nares. So nares is the plural word for nares, and here we can see that there are two separate openings or fossa that go through the front of the maxilla on this skull. So we can see that there's actually two here, and that's different from the class Mammalia. So continuing on with our key skull traits of the class Mammalia, we'll notice that there's actually a secondary palate on the roof of the mouth, if you will, on the skull of a mammal. So we have the maxilla bone is sutured to your palatine bone, and that's kind of the hard plate or the hard palate. But it actually continues on with soft tissue that separates basically your airway from your mouth. And the function of that is that it actually allows you to eat and breathe almost simultaneously. An additional skeletal trait that mammals exhibit is actually the one or single dentary bone that comprises the lower jaw here. And so that's different from reptiles that actually have four bones that comprise the dentary bone. And humans, for example, still have all four bones, but we have the single dentary bone, and then the other three bones, the incus, the malleus, and the stapes, are actually part of your ear now. So that's kind of interesting, a little evolutionary change there. So that's one of the key features, again, is that mammals have a single dentary bone. An additional trait is that mammals actually have differentiated teeth. So we're going to start by looking at what undifferentiated teeth look like here on our trusty reptile here, and you'll get an idea of what differentiated actually means. So if you take a look here at the teeth, they all generally have the same shape, and so from our knowledge of functional morphology, we would infer that they have the same function as well. And so if you can take a real good, close look there at this skull, you'll definitely notice that they're all kind of sharp and jagged. They all kind of have a pointed shape there. And so we would infer that that would be used for possibly tearing meat. That would be logical. So now what we want to think about is actually differentiated teeth. And for example, we have a dog skull, a canine actually here. And so differentiated teeth is where one organism has the presence of several different teeth that are either shaped differently, they're positioned slightly differently, and so we would again infer that they have a different function. So here we have, again, a canine, and we start in front with the incisors, and we'll get in more detail with these terms in just a minute. We move back to our canine, so obviously you can see a change just in the front part of the mouth here already. That we have incisors here that are still pretty sharp, and then we get into this really sharp canine, moving back to the premolars, and then all the way back to the back of the mouth with the molars. And so mammals exhibit several different types of teeth that have the possibility of forming different functions. So the function of those differentiated teeth that mammals exhibit is that mammals can be highly specialized in their feeding mode. So they can be very specialized in what they eat, what they choose to eat really, and the teeth are specific to that diet. So that is actually unique in the class Mammalia. Another key feature of the class Mammalia is that mammals actually only can replace their teeth one time. And you may know this if you've been to the dentist lately. So you start with your juvenile teeth. You'll lose those teeth eventually, and those will be replaced one time as an adult, more or less. And that's different from reptiles that can actually keep replacing their teeth. And so that would be very useful for them in the wild, I suppose. If you get in an ordeal with your prey and you lose a tooth, that's actually a very debilitating outcome of that interaction. And so reptiles can continue to replace those teeth, but mammals actually, they only have one chance to replace those teeth. And so that's a distinguishing feature of the class Mammalia. So when considering the idea of differentiated teeth on mammals, another sort of outcome of those differentiated teeth is the concept of occlusion. And what that is how the upper jaws and the lower jaws fit together on that surface where the teeth are occluding, where they're coming together here. And if you can imagine, we have several different types of teeth. So we have incisors in the front, canines on the sides kind of, premolars going towards the back, and molars all the way in the back. If those are even slightly a different shape, then that occlusal surface is going to be highly specific. So we've just gone through the main characters that you can identify if you've stumbled upon a mammal skull here, or mammal fossil. You can start to piece together the characters that you observe on that skull, and you can start to classify that organism. And if you can identify those features we've just discussed, that single nares, those differentiated teeth, for example, the enlarged brain case, then you might start to think to yourself that I might be dealing with a mammal here. And so those are key features, again, of the class Mammalia.